Let's see, the next one is the secondary memory. So as you have seen in the primary memory, they are used to store the data for the shorter period of time for the data which is going to be used during the program execution. But if you want to store the large amount of data like OS files, software and documents, secondary memory is required. Okay, and the first important point, it is not directly accessed by CPU. Suppose your CPU want to access your OS or files, software which are in the secondary memory, it must be transferred into the primary memory. Okay, so that is a concept of stored principle that we have seen in the early classes. Okay, and one of the important characteristic of secondary memory, they are non-volatile. We have seen this terminology many times. Non-volatile means the data will remain in the storage device even if electricity is gone, even if power is off. Okay, so that's why if you have a pen drive, the data remains there even if it is not connected to the PC or electricity. Okay, and secondary memory generally stores the large amount of data and very cheaper than RAM. These are the common things that everybody knows. And the examples you should remember, there are four examples of secondary memory: magnetic storage, optical storage, solid state storage and cloud storage. Okay, and we are going to see in the upcoming slides about each and every storage. So in the magnetic storage, first thing you should remember that it uses the magnetism to read and write the data. Okay, so with the help of magnetism property, it is going to read and write data onto the chip. Okay, and generally these storage devices are very cheap and it can store large amount of data. And example are magnetic tapes. So these are the tapes. So as you can see, ribbon is there. So ribbon has the magnetic characteristic over that. Okay, then we have HDD, that is hard disk drive. So this is the hard disk drive. So as you can see, there's spindle, platters, read write head arm. I'm not going to discuss about the internal of HDD, but remember it is a magnetic storage device. And a very older one is a floppy disk. Nowadays it is obsolete, but it look like this. And the most common one is the 3.5 inch floppy, which is used by the most of the people. Okay, so floppy disk is again a magnetic storage device. Coming to the next one is solid state storage device. Instead of magnetism, these type of storage device use NAND flash electronics. Okay, NAND is one circuit in the electronics which is used to read and write the data. Okay, so if you see HDD and SSD, it become very small in size, and NAND flash memory are also there, controllers and cache are also there. Okay, so the size got reduced and it cost also got reduced. Okay, so it become fast, compact and durable. And the examples you should know, it is SSD, the alternative of HDD. And whereas pen drives are also known as USB flash drive, and the thumb drives are also solid state storage device. In other words, they are also secondary storage. And the next one is the memory card, SD card, which are generally used in mobile phones right now. Okay, the next one is a optical storage device. You have heard the terminology like CD, DVD and Blu-ray disc. The full form you should remember: CD means compact disc, DVD means digital versatile disc, and Blu-ray disc. Okay, why it is called Blu-ray, that we are going to discuss just now. Okay, so first thing you should remember that optical storage device, as the word suggests, it is going to use some sort of optics. Optics means it is going to use some sort of light. So instead of magnetism or NAND electronics, it is going to use laser light to read or write the data. Okay, so how it is going to read or write data on the laser light? Because this CD has certain surface which is made up of polycarbonate refractive surface. This is for your information only, and it stores the data in form of some pits and lands. Okay, some pits and lands are there inside the CD or DVD, with the help of which it is able to identify whether it is 0 or 1. In other words, it is going to store the data in this particular device. And in exam, in SSC CGL, we have seen they have asked the laser light wavelength used in CD. So remember, the laser light wavelength used in CD is 780 nm, whereas in DVD it is 650, and in Blu-ray it is 505 nanometer. Okay, so CD around 700, DVD around 600, and Blu-ray around 400. So what is the advantage of having this wavelength? You can also think like the smaller the wavelength will be, narrow will be beam, and it is able to detect those pit, and therefore more data can be stored. Okay, so Blu-ray disc stores GBs of data, whereas CD generally used for storing the data up to 700 MB. DVD is generally used to store the data up to 4 GB. Okay, so for this particular topic, you should remember laser light is used to read and write data, whereas the wavelength used in the laser for CD is 700 nanometer. For Blu-ray it is 400 nanometer. And these are the 3 examples. Let's see the next memory, that is cache memory. And this is very important topic, and generally in exam it is asked from this cache memory. It is basically the memory which sits between RAM and CPU. Okay, so your CPU is there, RAM is there, so near to CPU one cache is there, so it sits between RAM and CPU. The next one, where it is located inside CPU or near the CPU. Coming to the next, this one in the last year we have seen in the CGL, a very difficult one. On what principle this cache memory is used? It is based on the locality of reference. Means the nearer the data, the nearer will be the reference. Okay, the faster it will be. Okay, so the locality of the reference principle is used in the cache memory. And obviously it is a volatile because it depends upon the electricity to operate. And the next one, it is more faster since it is closer to CPU, more the faster, and it will be smaller in size. It is not like secondary storage device or the RAM. It is generally smaller in size, of having size 256 to 2 MB. Since it is very smaller in size, it is expensive. Coming to the last topic of this particular session is the memory hierarchy. And as you can see, the more closer to the CPU is registers. Okay, but before register, one important electronic circuit is flip-flop. What is flip-flop? Flip-flop is again an electronic circuits which is used to store 1 bit of data. Okay, and in exam we have seen this question, like he will ask which of the following electronic circuit is used to store 1 bit of data. Your answer would be flip-flop. Okay, flip-flop is used to store 1 bit of data. Coming to the next one is the register. So as the diagram says, the more you go closer to CPU, faster you should be, and the size it will be increased. Okay, so the hierarchy is registers, after that cache memory, then you have main memory, secondary memory. Okay, so if you ask like which of the following memory is the fastest, your answer should be registers. Okay, so out of these thing, okay, registers are the fastest one. Why? Because they are closer to CPU. Okay, afterwards it is the cache memory, afterwards primary or main memory, and finally the secondary memory. Okay, so this is a memory hierarchy. Remember, the fastest one is the register, then cache memory, then primary, then secondary. It is not the cache memory It is the registers, again I am repeating, registers are the fastest memory, whereas the slowest one are the secondary memory. Okay.